Ethan, thanks for taking the time to join us. So you've invented the first ionocraft, to my knowledge, that carries its own power supply. Is that correct?
Right, right. It's patented for lifting its power supply against Earth's gravity, and there's two patents for it. Uh, and it was not easy to do, and a lot of people thought it wasn't possible. And all the textbooks say that ion propulsion can't lift against gravity. It's nowhere near. It lifts like creates like millinewtons of thrust per watt typically. So it's not. It wasn't considered possible.
Yeah.
And but there were these things called ion lifters that are all over the internet. And before that, they were called ionocraft. And a guy made one that would swing around a pole in the 50s with a big, huge external power supply. And then in the 60s, in 1964, a guy patented a device that made of foil and aluminum foil and wires and balsa wood, and it would float up into the air. But again, it had a huge external power supply that would sit on the ground, and they would feed high voltage, powerful high voltage to it. So they were interesting contraptions, but they were very far from flying with a power supply. So it's all about thrust to weight ratio. So I
How did you
started
get
building
involved
it.
in those?
Well, I uh, I was working in a on jet engines in the shop when I was in my 20s, and I thought, wouldn't it be cool, to have a jet engine that would have, like, if it was electronic and you could make the air susceptible to magnetism, then you could fire the air through a series of magnets, right? And you could just have like a Christmas tree circuit, to fire the magnets sequentially
Yeah,
to
like
activate them.
like the Lorentz effect, like a rail gun, right?
Yeah, well, the railgun has two rails that are charged and things
Yeah,
jump,
like a
through
magnetohydrodynamics. Like I know they used
kind
that
of, yeah.
that was experimental, like in Red October, and they did a few experimental craft. But your idea is essentially more of a coil gun with multiple stages, or a rail gun with just the two big rails originally.
Yeah, right. Well, it's not quite like the rail gun thing. It's more like
Mhm.
just I have a coil magnet and then another coil magnet and then another coil magnet, and
Yeah,
they
like
just
a coil gun or a maglev
switch
train with multiple
sequentially,
stages.
timed,
Mhm.
in a timed sequence. So, I was trying that, but it requires a lot of energy to ionize the
Mhm.
air, and then you have all the weight of all the magnets, and you end up with not a very efficient system. So, and then I was Googling and I found this old video from 1964 of a guy named Major Desiversky, who made a bunch of fighter planes back in the day, back in the 50s and between the 1940 and 1960. So he came up with this ionocraft, that I was talking about before, that had a huge external power supply. So I thought, wow, that's a neat thing. It doesn't need series of magnets. It's electrostatically, accomplished. The air is moved electrostatically. So I started copying his patent, and at first I couldn't make a device that would fly, but I did make a device that would blow some air and would make a candle flame lean over, from the ion wind. So, and then I came up with this idea to have a triangular piece of foil with round holes in it and needles hanging above those holes on a non-conductive mast. Needles, but they were actually, wires bent down, like needle points. And then that produced enough lift when it was connected to an external power supply to jump up in the air. And when I switched the wires properly, it flew all the way up to the ceiling, you know?
So
So
would
I
you
was,
say that the ceiling really foiled your attempts at an early lifter?
yeah, well, it was just so exciting. I wouldn't say it. It's pretty funny, but yeah, I was, in my, I was in my early 30s at that point. But anyway, So, called I was at my mother's house back then, and I called her to come in. I said, come quick, look at this thing, and she came in and she looked extremely worried and shocked, to see this thing floating up near the ceiling. So, so then I switched off what I was using was a computer monitor. Well, at first I was using a big screen television. They have the old-fashioned ones had a big transformer inside.
Mm.
And the transformer, the signal's rectified so that it comes out as a high voltage DC direct current. And I ran wires out from that. And so when you switch the monitor on, the thing, would take off, powered by that large external supply. So I thought, well, I don't need that big television or big computer monitor, which was a later, thing I used. I thought I just need the transformer from inside of it, so I'll make this transformer driver. So I started looking for circuits to run the little they're called flyback transformers,
Mhm.
which is basically what everybody uses nowadays to run lifters, which is a later thing. So um, I made this little circuit, this very small, and I ended up finally getting the transformer into a flashcards box. I got a smaller, a flyback transformer, put it in a flashcards box, and got a couple motorcycle batteries to run run the thing, off of DC input, and then the circuit goes in there and and creates a fluctuating current that um, causes the transformer to come on. And so then I had this little portable power supply, but it still probably weighed, 10 pounds or something like that. I don't know exactly. And and then I had that little triangular craft I was telling you about with the holes in it, and it would jump
Yeah.
up into, you know. So so that was cool. So then I started looking for smaller transformers, and I started taking apart the transformers, the
Mhm.
flybacks, and I thought, do I really need all this current, from this big flyback? Maybe I can run with low current but high voltage. So I thought, well, what about ignition coils? They have really high voltage, but the current's not as bad. Yeah. So there was automotive ignition coils, the old ones. They're like big oil-filled thick can,
Mhm.
but they're heavy. So I thought, hey, how about a motorcycle ignition coil? You know, so they're small, about like, depends on the motorcycle. I ended up developing drivers for those and using small motorcycle coils, and with a voltage multiplier on the output of that
Mhm.
coil, it would put out a high voltage DC at a lower current, and the crafts would still fly with that. So then I'm going into a lot of detail here. I don't know if I'm
That's
going
fine.
into too much detail. So you understand what I'm talking about, these things. You've seen them probably. So anyway, I broke open the some of the ignition coils, and I looked in there, and I found some ignition coils that had a ferrite core. Instead of a
Mhm.
steel core that the wires are wrapped around, it had a core made of ceramic that runs at a higher frequency, and those coils were smaller and lighter. So, because whenever you run a transformer at a higher frequency, it can be smaller. So I started winding my own and carving my own cores with a Dremel tool, and a lathe and so on. And I started using like EE cores. They're more efficient than
Mhm.
just a rod core. It's called an EE. It looks like two E's facing each other. Are you do electronics
Yeah.
somewhat?
I'm
So
basically a biomedical engineer at heart. So
okay, yeah,
I
yeah.
do some
So
most of my electronics are signal acquisition stuff, as well as
okay,
some
oh,
ultrasound devices.
I see. So that's interesting. So so anyway, that was the early things. I used EE cores. I started making thinner and thinner ones and smaller ones, and using thinner
Mhm.
wires and tensioning systems to tension the wire. Instead of at first I was using like a cordless drill and winding like with a cordless drill, and then
Yeah.
later I got the high-tech tensioning systems and lathes. And then I tried, I have like a whole bunch of different spools of wire, large variety that I went through. So then I found inside of older laptops, they had a thing called a CCFL inverter,
Hmm.
which is a tiny little transformer
Yeah, this
strip.
is like 90s era laptops, or
Yeah, and like 90s era laptops,
yeah, I saw a
maybe.
few of those at like old trade shows and stuff.
Yeah, it may be even early 2000s they still
Hmm.
had them. And so I found that you could use these little inverters. And there was an inverter that was used on the space shuttle for fluorescent lights called the BXA 302 that was sort of like a postage stamp. And it ran, it was designed to run 3.5 volts and so I thought, well, gee, I could use with a tiny lithium polymer battery and this very small inverter, and I ran it through a large voltage multiplier. And that would also fly through
Hmm.
fly the crafts. So I had this circuit that weighed, and then I got rid of the circuit boards, just connected the pieces together point to point and changed a whole bunch of parts around, and upgraded things.
Hmm.
And then I had a circuit that weighed a power supply that weighed 5 grams, right? So it went from like, 10 pounds to 10 pounds down to 5 grams.
Yeah, that story sounds very electrifying.
Yeah.
I got a charge out of it. So after it's 5 grams, what's the next step?
So I thought, well, I had been studying for many years, all my life. I was interested in there was human-powered aircrafts I saw,
Hmm.
that and one thing called the Gossamer Condor was the first really effective human-powered aircraft. And in order to lift a lot of weight with a small power supply, you need a really large wingspan or a really large surface
Hmm.
area. And then you get a lot of lift with a small a thrust. So back when that human powered aircraft came out, I drew a picture on a napkin. That was back in like the 70s, I think. I drew a picture on a napkin, and I thought, if they make a large enough wingspan, they make it light enough, they use hang glider technology because I'd been building hang gliders back then as a kid. Um, I thought, well, it could make a practical human powered aircraft. You could do a better job, and there was a prize offered for $100,000 for anybody that could fly, like I don't know, half a mile or so around a couple of poles and figure eight pattern.
Hmm.
So about 2 months after I drew that picture on the napkin, they came out with the Gossamer Condor, which looked very much like my picture I drew. And I thought, wow, man, I was on the right track. I wish I'd have built it. So, so
Sadly, the idea didn't get off the ground.
yeah, yeah, for me at that point,
Yeah.
yeah.
But a lot of
So,
good ideas in engineering start off on the back of a napkin.
yeah. So, I was excited by that. And then, so then we, fast forward up to the ion propelled vehicle project. Um, uh, I see there's a bunch of stuff to say about it, but I realized that it needed to have a large surface area. The structure had to have a larger surface area and be very lightweight. And that way I could generate a lot more force with a
Hmm.
tiny circuit, because I
So like
needed to
an
get.
upside down rabbit ear antenna or one of those old laundry lines up like my grandma's old laundry line turned upside down. That's what the first my first thoughts when I saw one of your ionocraft was. Like the old TV rabbit antennas, like some kind of wire sculpture, basically.
Right. Well, it looks, like sort of basic when you first,
Hmm.
see the drawing of it or something. But it's actually very high tech and complicated. It evolved. There's thousands of little details that evolved over years. I've been doing it for 25 years, every day. So, and basically every day. And it's it's the structure that holds it's got emitters and it's got collectors surfaces. The collector surfaces are large, rounded, metallic, in shape, and the emitters are extremely fine, thin wires. And a lifter, which you've probably seen ion lifters before, is typically a triangle, but it could be many shapes. but when they talk thin wires, they're talking 250 microns, or maybe somebody used 150, but typically it's more like 250 microns. My wires, emitter wires, are 2.5 microns thick, right?
Mhm.
So it evolved down more and more. And I even read some place that on a person's website that there's no point in making the emitter wires too thin because there's diminishing returns. But that's not true. From my experiments, I found out that the thinner the emitter wires, the better. So I found out that you had to use tungsten because if you use copper emitter wire, it just breaks.
Mm.
You can't work with it that thin. So I use tungsten, and then
Yeah,
I have a
tungsten, that's a
special.
pretty metal story.
Yeah, it's heavy metal. So anyway, the tungsten uh, was I don't have it free hanging like on a lifter,
Mhm.
because it's so thin. It's kind of worrisome to have it just hanging there. So I have a special filament, and I glue it at short intervals to the filament,
Mhm.
to the real strong filament, and then it can take actually quite a lot of wind due to the physics involved.
Mhm.
So and that tungsten, there's hardly any current that the system needs. As it turns out, you can run on very low currents if everything's designed right. So and with a low current, then your power supply can be small and light. Yeah. Because if you needed a lot of current, the power supply would have to be heavy, big
Mhm.
and heavy. So also, a lifter has an emitter wire and a collector, and they put them, they get a pretty strong power supply, and they put the wire as close as they can to the collector before there's a spark, and you get the most lift that way. But it draws a lot of current, and it's not efficient. So you end up maxing out at about a gram of lift per watt,
All
gram
right.
of thrust per watt. And best case scenario, it's usually less than that. And but if you put the emitter wire way up high, like a 6 inches up high, it's 15.2 millimeters or centimeters, and then it gets real quiet. Instead of making a loud hissing, crackling noise, it's like almost silent, and you get it gets less lift, but a lot more lift per watt,
Mm.
right? Especially with that extra thin emitter wire. So I was able to get the thrust per weight like about at the frame, it's about 14 grams of thrust per watt of power that actually gets to the structure. And at the batteries, it's about 6 or 7 grams of thrust per watt. So there's power loss in the circuit. The transformer gets
Mhm.
hot, when it's taking off vertically. Um, so those are some of the technical details that.
Well, what do you think the most exciting or rewarding thing about the project has been?
Uh, uh, well, there's been a bunch of moments, when like um, that first moment when it took off, and it wouldn't fly, but it was blowing a little wind and wiggling around, and I switched the wires, the polarity.
Mhm.
It was kind of against the literature to put the polarity. I put the opposite polarity on the emitters,
Mhm.
and that's when it flew up to the ceiling. That was very exciting. It's like, oh my God, it works. And before that, when I made the candle flame blow from the electric wind, I realized that it was that there was a such thing as electric wind. So, and then another moment was when I got it to fly hanging from a postal scale,
Mhm.
hanging scale, and it would take off for a second, and the thread would go loose that it was hanging from, and I thought, oh my God, I'm lifting the power supply, you know, but it's only for a split second,
Mhm.
but the transformer would get hot and so on. But I thought, well, if I could just make it a little better, I know I can do it for longer.
Well,
So,
what are the main what are the main flight limitations right now?
well, the transformer was getting hot.
Mhm.
So, and that was wasting half the power,
Mm.
you know. So, and the transformer is like 90 some percent efficient. I made it ultra efficient, but when you floor the thing to take off, it's just a little too much for the small transformer. And it goes into what's called saturation mode,
Hmm.
where it's on this curve where the power current draw spikes up. So, making it slightly lighter makes it get rapidly more efficient. Make it putting a slightly less
Hmm.
load on the lower load on the transformer. So what I did was what I'm doing. The newest one is much lighter and stronger than the previous models, and uh, so that's going to make it a lot better. It should fly for maybe 5 or 10 minutes now instead of 2 minutes,
Hmm.
right? And there's been also the steering. I had to um, do all kinds of different types of steering to get the steering to work well because it needs very good control to prevent crashes, you know.
Yeah.
Like if you get a little quadcopter and it crashes, you just most of the time you can just go out and fly it again, you know. But with this thing, you don't want to crash it, you know. You want
Yeah.
it to be very,
So the
very stable.
delicacy of the craft is one of the limiting factors as well, structurally at
Yeah,
least.
structurally it's very complex and
Hmm.
it's delicate. The patent drawings make it look pretty simple, but there's actually a lot more support filaments and structural
Yeah, there
components.
always is, especially like speaking from 3D printing, how it looks on the outside, it often is much more complex inside.
Right, right. So you were talking about the original question was had to do with the limitations, the things that were keeping it from being better, right? I forget. I don't know. I don't think we're going by the questions list. I
No,
think it's
it's much more fun when it's a little bit more spontaneous, I
yeah,
think.
spontaneous. Yeah.
Because like
So
what I don't want it to be just like a robot checking down on stuff on a list, but
no, right.
what about the most disappointment you've had with this project or the low
Oh,
points when you crashed quite literally?
well, it crashes. It's been through a lot of crashes, but I usually use tie down. So when it does crash,
Mhm.
it's a minor setback. Not in every case. I mean,
Mhm.
it's been through thousands and thousands of flights. You know what I mean? So there's been many crashes. But the biggest setbacks, I had a fire a while back. I made a gold metallized vehicle, a real pretty one. It's on the
Mhm.
website and there was a high voltage plug on top of it, a tiny little micro plug, and it just wasn't plugged in well, and it made a little arc, and the support filaments were ran across that plug, and one of them caught on fire, and the fire just went right down the support filaments and burned them all out, and then the thing collapsed, and I was like, oh my God, it was it was upsetting. So I managed to fix it, but it's not quite straight anymore. And it added about a gram to it to make the repairs added about a gram. So, um, yeah, there's some, negative things that have happened, but when you're inventing, when you're doing experiments, when something's negative, it's usually a learning experience, right? So you expect, two steps forward, one back, two steps
Yep.
forward.
Because sometimes it's the errors that help you more than the limited successes in the
Yeah, yeah. If everything's successful, you didn't learn anything, right?
exactly.
Except,
Well,
yeah,
this is why, like, a saying I've heard in engineering is you never trust a clean workbench because it means that nothing ever gets done there.
yeah. Yes. Well, I mean, I hate
I'm not
to
just
say
talking about
this.
organized, but if it looks a little too clean.
Yes, I agree with that. I mean, for most of these years, my shop has been pretty. There's so many little parts everywhere and so much going on that it's very hard to keep it, pristine looking. But after a while, I'm doing videos and having people coming over to look at it, and it's not good to do videos and have stuff, a bunch of equipment piled up all around the thing.
Yeah.
It's nice to have a cleaner place to present to people. And once you get organized, then you can find stuff because otherwise you spend, 2 hours
Mhm.
looking for a little component and 1 hour, half hour working on it.
Hmm.
So being organized is just a wonderful. Recently, I've got better organized, and I find it's less stressful to be able to find things, you know.
Yeah.
So
Well, one question would be, what what major advancements do you think could help this technology? Like I know you mentioned the heat on the transformer, but what about some of, say, using laser-induced graphene as a heat sink, a really light material that's darn good at thermal absorption?
right. Well, I already am using. There's a oh, what's it called? I'm thinking it's pyrolytic graphite sheets.
Hmm.
Have you seen those before?
Yep.
Yeah, I've got these pyrolytic graphite sheets. I think they're about 25 microns thick.
Hmm.
They're extremely thin, and they have this, adhesive on one side. Some of them do, some don't. But uh, by sticking those on the transformer and making a bunch of fins out of those, it can reduce the heat of the transformer by about 10 degrees, and they weigh, like 100, 200 milligrams.
Yeah.
Whereas a normal heat sink weighs more like, I don't know, 800 milligrams or something,
Yep. I think
material.
carbon and a lot of the fullerene materials are like a lot of the cheat codes in materials science.
Right. Yeah. I've got a box of nanotube threads in the other
Yeah.
room.
Talking about
And
thermal management and electronics is always a hot topic.
yeah,
Some
exactly.
some think it's really cool though, but hot and cold aside,
Mine like
uh,
that. Yeah. Yeah.
what would you think would be much more helpful if in helping bring this technology to light? What do you think someone could do, or
Well,
if we had government support, major corporate support, or someone that could help bring this thing into some kind of role? What would be the things you'd use that, and how would you like use those resources?
well, right now, I mean, there's a whole bunch to say about that, and it's super exciting.
Hmm.
Right now, I'm working on a new craft that is much lighter, and it's got gold metallized materials that are lighter, and so they won't oxidize or tarnish like the older
Hmm.
crafts. But once I build it, it'll just keep working. And electronics, once you get them, properly put together, are relatively reliable.
Hmm.
So because there's no moving parts. Although mine does have these two tiny switches, but for the high voltage to make it steer
Hmm.
in the four directions, and
Hmm.
also it's got two twist fins for yaw,
Yeah.
right? But the yaw is kind of optional. But
Hmm.
um, anyway, but I have built a yaw system and used it several times. But so those little switches, they had 2 grams of force, the ones I had before, and one of them wasn't really working all that well. And now I have some that have 4.5 grams of force, and they're lighter. So that will be, switch the high voltage extremely effectively. And those had to evolve through a bunch of different stages to get them to be light enough. So, but anyway, this beautiful new craft's coming out. It's much stronger, with miraculous improvements in strength and lighter weight, which makes a big, it's not linear. If you can take off, 5, 10 grams, it makes it work marvelously better. So, and then in the further future, there's just so many ways to improve it. I mean, you can some of the older models carried propellant tanks,
Hmm.
and and so once you have a propellant tank, it'll work in a vacuum. And it's also proven that the speed of those particles that come out is proportional to the voltage,
Hmm.
input voltage. So, some people say that it's not that it's more of a logarithmic curve, somewhat. It's not entirely, directly linear. But some of the research that people did shows that it is closer to linear than logarithmic. So some of the experimental results. So
That's quite
um,
shocking.
yeah, it's very shocking. You have to be careful not to get too shocked, but shocked bad. So anyway, as I found out the hard way, but
So if
so
someone tries to make a fraudulent version, do you think they'd be charged?
Yeah, I think so. I think you get charged up a lot. But there's a company that has one that has a huge ducted fan in the middle, for instance,
Mm.
and they say it's silent and it's totally ion propelled, but I mean the thing weighs like 10 like 25 pounds or something, and it's got obviously a 3,000-watt ducted fan in the middle. So
Yeah, you could say that that blows.
yeah, yeah,
But
right.
circling back to some of your original inspiration, you mentioned I think it was like a Soviet fighter pilot or aerospace engineer, right?
Yes, yes. He was a aerospace engineer. He immigrated to the United States and made a bunch of, I think, P-35 aircraft, a bunch
Hmm.
of famous aircraft, and he wrote a book about winning the war, World War II through air power. So he was a famous guy with he had some factories that were absolutely huge. Like those huge, the largest of aircraft hangars, and it said Seversky on top of the hangar.
Mm.
Like he was really a successful guy, and he made that ionocraft with a big external power supply. But it was the
Yeah.
first one to float vertically. So
But what about using the ionocraft to supplement other types of more conventional propulsion? Like even if I get a weather balloon and use this as to move it around with more precision, for instance.
sure. Well, people have been doing that for quite a while, and I in 2003 I made a lifter like craft with a big balloon over it, sort of a flattened rocket shaped balloon made of
Mhm.
clear balloon plastic, and I could hook the wires up and it would float up to the ceiling, and then disconnect the wire and it would float back down again. Which was kind of cool, but it's not fast. And there was a guy in 1977 that pushed a blimp with I can't think of his name right off the bat, but he pushed a blimp inside of a warehouse at a military base, with electro aerodynamic thrust. But the thing is that they it moved very slowly. So it's see what we're really talking about here are ion rockets.
Yeah.
Okay, it's not a helicopter and it's not a airplane or a glider. It's an ion thruster. And
Well,
so
one question would be, because it's a thruster, do you think you could have a bunch of them at angles to move something up?
sure,
The
I
reason I
mean,
bring this up is you ever heard of this is an old idea from the mid 20th century. You ever heard of the raccoon?
uh, I it seems like it, but anyway,
Well, it's
go
using a
ahead.
weather balloon to launch a rocket.
Oh yes, yes, okay,
So
yeah, yeah,
when one of the problems is for larger rockets, it's hard to get the balloons in the right position. So maybe something like this, a few of these with the weather balloon could get a larger platform, so you could get larger payloads and maybe get something that actually could do escape velocity, or at least get higher than than the crappy single stagers they've been using so far.
yes. Well, I mean, it absolutely can do. People don't realize, Remember I told you I started off. Maybe it was before you pushed the record button, but we were talking about that sci-fi called They Live, you know.
Yep.
The guy could not get people to put on the glasses to see the truth. He just couldn't. He had to get into this fight for like 10 minutes with his best friend to get him to put on these glasses to see the truth. And sometimes I feel like I can't get people to understand the importance of this technology. They just won't. This technology, uh, it's an ion thruster. It's a rocket, and it with a solar panel or a beamed power or a really good battery, it will run way longer than a chemical rocket, right? And it doesn't need a chemical rocket needs a huge tank full of
And
propellant.
recovering the stages or having them burn up in the atmosphere and all the
Sure.
waste.
It's a big problem, because of the physics of the rocket equation. You need a lot of fuel, a huge thing. People
Mhm.
imagine they think, oh, rocket, 200 feet tall and 5 million pounds of thrust to carry one astronaut. But when it comes to ion propulsion, you only need a tiny little propellant cylinder to run for, I mean, to run for months. It's way more efficient than a chemical. Chemicals like dinosaur stuff, you know. It's
Yeah, they've literally been
old-fashioned
using chemical
technology.
rockets for 1,000 years, more than
Right?
that.
Yeah, literally, yeah. More than that
Because
probably,
the
you know.
first
It's
gunpowder
BC.
weapons weren't firearms; they were fire arrows, like crossbow bolts and arrows with firework rockets attached to them.
Yeah, it probably scared the crap out of them.
Yeah, like one of the, I guess, famous early rocket artillery platforms was used in the 1590s, used by the Koreans against the invading Japanese samurai, a conflict called the Imjin War, where there's a bunch of firework rockets attached to arrows, and they light them off and do it from a mountainside because at the time the Japanese had the better, more experienced army, but the Koreans had the better artillery. They would just kind of fall back between mountain passes that were easy to defend with art and pounding everything with artillery as the
Right.
Japanese advanced.
It's so interesting, the history of rocketry, you know, it's
Yeah, I'm
just
glad they could get it off the ground.
yeah. Yeah, I think it's
But
wonderful, you know,
what?
and particularly for space exploration, you know, rocketry is, you know, has been always great. And this thing, you know, it makes a silent flying vehicle, you know, like a silent version of a quadcopter or something.
Yep,
Um, it doesn't currently have as much thrust per area, so it has to be lighter and larger, you know, for to get enough thrust to work properly. But there are ways to get more thrust than propellers probably with it.
yep.
More thrust per watt.
I know there
And
has
so,
been recently. I know this is probably more recent, but there's been a new type of electrostatic motor. I think someone patented that gets more efficiency than the regular electromechanicals, but that's still just a variation on propeller tech. But
yeah,
something a bit more interesting might be ionocraft combined with maybe like a jet intake or something like that. Because there's a guy on YouTube who made like a mini ionic turbine, for lack of a better term.
I've seen that thing. I talked with him once in an email or a comment or something. It was a long time ago, but yeah, it's a fascinating thing. I think it was maybe originally Townshend Brown idea. But
Yeah,
somehow, you know, they mix you know, burning propane with you know, ion thrust, and you can get it can regenerate some of the high
yeah.
voltage that way.
I know MIT. They made like a essentially an airplane or a glider with a simple ionic propulsion on the wings. So,
Right.
and back at the time, it was all exciting. There was a lot of media just because MIT has good and
Yeah.
great media reach. And whenever MIT comes with something, a lot of the science media is like lining up for the story. So,
Right. Right. Well,
if
I
you have
tried to put
friends
a
to in
comment.
the
I,
Mhm.
yeah, I tried to put a comment under there. Said, you know, look, I have a patented already with one with onboard power, and they wouldn't allow my comments. You know.
Yeah, I can kind of relate because
So
one of my inventions that it's been done for decades, but just because of the way that the a press release phrased it, a lot of people thought it was
yeah.
new at the time, just because a lot
Yeah,
of
they
technologies are
say they're
obscure.
first, and they weren't, you know, that's not correct. And they did the same thing with there was a propeller that has a rounded end on it.
Mhm.
I forget exactly what it's, you know, exactly how it goes, but there's a propeller with kind of rounded ends, right? And they're been sold for a long time, used for boats, and they've been around for a long time. There's a whole bunch of patents, and they said they invented it, you know. I mean, so it's like a repeating theme, you know, of them, you
Yeah,
know,
it's basically advertising at the end of the day.
yeah, I just don't understand any of that. I was, you know, when I was, you know, I mean, during most of my life, people are, you know, a lot more honest, you know, but you have to, you know, I mean, we live in times when people will, you know, put a thumbnail, you know, on you click on a thumbnail and it says something and it's
Well,
not
didn't
what,
we already kind of arguably have that for a long time? Like, I mean, remember the Maine back in the day, and we've had
yeah.
advertising in newspapers as well
Yeah.
as the state-sponsored version throughout the last couple of centuries in various forms.
Well, there's always been like white lies, like, you know, best coffee in the world or
Mhm.
something. You know, it's not really, you know, it's just regular coffee. Uh, you know, it's one reason I like that science fiction movie. You know,
They live.
they live, yeah, because there's this, you know, thing. It shows a woman smoking a cigarette or whatever, and then he puts on the glasses and it shows what it really says, which is, buy only our cigarettes or whatever,
Yeah.
Um,
So
uh,
it's kind of like I don't know if you know the philosopher Hegel, but dialectics in action. It's like there's the initial concept of something, but once you look deeper, you get the material reality, and it's kind of like that ongoing cycle of discovery of the idea that you originally had, its opposite, and kind of realizing what it truly is, or what kind of truly drives everything.
yeah, it's so wonderful to see that, to start off by seeing the truth, the basic truth of things, as best as much as possible. So
Well, what about simply commercial interest, or at least the lack of having your own press release department as a small or independent inventor? That could also be a factor.
yeah. Yeah, as far as commercial, see, somewhere around here, there's a lot to say about that, but anyway, I don't know where it's written down, and I'll just but tell you what I know about it. Um, I think that a lot of people aren't clearly seeing, that it's an ion thruster, and that means that it can work like a chemical rocket for lightweight loads, only it'll run for weeks or months instead of 10 minutes or 5 minutes. And it doesn't have to be, I mean, in order to make a rocket work for 10 minutes, it needs to be 200 feet tall, and put out 1 million pounds of thrust. And for mine to go for 10 minutes, you just need a little, a tiny little solar, piece of solar film, and it'll run all day.
Well, what do you think
So,
about wireless power transmission, like to keep an
yeah,
airborne platform steady?
I can buy for wireless power transmission, I can buy a solar cell that's just tiny, like a postage stamp, that will probably give off produce about 200 watts,
Mhm.
right? I'm giving a rough number here. I have to go look back at the numbers, but it's something like 200 watts for a little tiny concentrator solar cell. And if you shine a laser at that solar cell, you can get 200 watts of power and have no battery weight. And as long as you can track that, as long as you can keep the laser aimed properly, uh, you get all the power you need.
Yeah,
So
I know it's something I didn't mention, but did you read much of that paper that I sent you?
I haven't read
That's
much yet.
very
I'd like to
relevant to
post it.
that. I don't want to spoil it. But let's just
Okay,
say
I'll
it's
read
a
it.
lower cost method of wireless power transmission that is very relevant to some of our prior correspondence.
Yeah, I would definitely will read it.
Well,
Finish
using
reading
lasers for
it.
power transmission is very illuminating.
Yeah, that's
Otherwise,
definitely.
we'd all be in the dark about it.
Yeah, my God, you're yeah, good at this.
Well,
So good interviewer.
but as far as some of the any notes you any advice you'd give to younger students nowadays?
Um, yeah, well, of course, regarding this subject, I would say just follow my patents, follow my patents, look at my website and my YouTube channel, Ethan Krauss YouTube channel. And there are like 40 some videos on my channel, and I got about 50 that are public. And in all the comments, I explain things too, answer people's questions. And on my website, electronairllc.org, I answer a bunch of questions. And if you copy my 25 years of experiments, it can save people, decades of fiddling around, and you can make one that carries its power supply. And in the future, there's just no limit to what this can do in the future. I mean, this thing it only ionizes just a couple percent of the oxygen in the air. That's how it works, right? So, I mean, once you start ionizing all the oxygen, it's going to be just amazing, you know.
Well, I think it's very electrifying. But any advice for any dispirited inventors or anyone like that?
It's a hard gig, It's like, before being an inventor, I was a musician
Mhm.
and a guitarist, and people are saying, um, you can't make it in music, it's too difficult, and so on. Um, yeah.
Would you say that if you
But
use guitar wire for this, it would be high strung?
yeah. At one point, I used actually to be a literalist, I actually used 8 gauge and 7 gauge strings for switch springs, from a guitar string. But then I ended up moving on to thinner materials. But that's funny. But yeah, so as a musician, you encounter a lot of, not everybody, even the Beatles, some people didn't like them, burned their records and so on. So there's a lot of you got to prove them wrong, when
And the
someone's
best way to
negative.
do that, you think, is with something that actually works?
Yeah, right, exactly. And so yeah, that's the thing. That's what makes
Demonstrate
them.
results.
Yeah, demonstrate results, and the better the results, like I said, it's hard to get people to see all the value in this, without seeing something actually go up into the sky, clouds, and go into orbit or something. So, or fly right in front of them. So, but once I fix it so that it flies up and down the street, and there's a lot of people watching. I mean, I do have some videos with a lot of people watching, but some of them it didn't work as well as others, and but it always, all the videos I posted, it did work at least some, and some videos it worked quite well, so um, uh, it's yeah, you got to get people on your side as much as you can, and
Yep.
you got to be your own cheerleader, basically, and I want to mention too that it helps to have a wife who's on your side. So yeah, it's very important, and
Yep.
yeah.
All right. Well, anything else you'd like to add?
Just that this is it's verified, every way, including Sunday or whatever, however you say it. It's been verified very well and clearly. It's not a fringe thing in any way. It's like as solid as can be, and I've made sure that it's clear, that it does what I show that it does, and it has such fantastic implications for the future. One word for it is space probe or starcraft. I mean, something that can accelerate at better than 1G, which this does, for months at a time, weeks or months. And with a laser, it can accelerate at 5, 10G, no big deal, comparatively. There's nothing that is better, that has more potential, you know, right? So that's that's probably the most electrifying thing I could say. So
Yep. Well, if you drink enough coffee, it'll be better because you're wired.
yeah, oh gosh, yeah. Well, I usually do drink plenty of coffee, so
Yep. Well, it's quite a jolt.
yeah.
All right. Well, if someone was ditzy when if they try to build this, I guess they'd be an airhead.
Oh geez.
Well, what I'm looking forward to is if this invention ever becomes very common, I would put LEDs all over it and fly it outside of a relative's house who believes in UFOs
Yeah, oh yeah. Oh
to prank
God.
them for Halloween or April Fools or something.
Yeah, I have I thought back. My mind wanders sometimes, but I thought back. And years ago I made a solar car, several solar cars, and I had one in a like a work trailer, big work trailer.
Yeah.
And I opened the door to the trailer, and it was kind of in the dark, and this solar car was in there, and it looked like a spaceship kind of. And then I let someone look in. They said, "What is that thing?" They looked kind of scared. I said, "It just fell out of the sky one day."
Yeah.
And they were absolutely like scared. And But yeah, people that UFO people find this quite interesting for some reason, and I find UFOs are quite interesting, but you never can get anything
Well, the
really.
best UFOs are those
Oh,
that we make ourselves.
yeah, right. Yeah, the best ones are identified flying objects because we it's something we can we can learn about and put our hands on, and
Well, not
um,
maybe not this one, just because of the high voltages and the how
yeah.
delicate some of the parts are.
Right. Well, I have, touched it while I was running with, put my fist against the side of it or something, and it doesn't, the shocks are not usually not, not too bad. But if you grab the power supply with two hands, it's not a good idea.
All right.
So
Well,
yeah.
thanks a lot for your time, Ethan.